Welcome back, chemistry fans. Today we start a brand new unit. It is unit 9. I'm almost out of fingers to do this with. And this is all about attractive forces, which is a synonym for intermolecular forces. So let's jump into it. Love talking about intermolecular forces. They explain a lot of fascinating aspects of the world around us. So let's jump into it. Intermolecular forces, attractive forces. These are what binds together molecules so that we actually have liquids, and why everything doesn't just float off the earth. So what we do to get into this is we first have to understand those different states of matter. We have 3 different states of matter. We have, of course, a 4th one, but we don't talk at all about plasma. It is hard to measure, it is hard to predict, and so we just kind of ignore it for the most part. We will stay focused on solids, liquids, and gases. Solids, they are in a fixed position. Liquids, they are like gases, they are fluids. They can move about one another. If we are converting solids to liquids, we call that melting. Liquids to solids, we call it freezing. And then liquids to gases, vaporizing, condensing if we reverse it. The one that is not on here, however, which should be included, is solids to gases. That's called sublimation. And then gases to solids, that's called deposition. Now, in all of these, as we're moving left to right on this chart, what we should start to see is that there is an increase in energy. As we heat up the solids, it will convert through those different transition states, transition methods, and they will start to become further apart. And as they move further apart, because there's more energy, the attractive forces holding them together start to break down, and eventually they become so weak that they have no association with one another, and they just become so fast that they bounce off of one another. They're moving faster than the attractive forces of the molecules. So this chart, again, restates what we just talked about. Solids tend to only be able to vibrate around one particular position. Liquids move around, and gases can move anywhere. Gases are they have the highest amount of energy. They're the furthest apart from one another. They are moving the fastest, and they have a random movement to them. If we wanted to associate that with images, here is showing the motion of the solids as being vibrating with those parentheses around the individuals, and then the lines on the liquids are smaller than the lines on the gases. Now, one of the details that we need to be able to associate with this is the idea of the mole map. We have talked about the mole map before, and so this is not something new for us. But what we have been focused on so far this year is just this solid side. We have not been associating it much with the gas side of this one. So whenever we made all of our conversions, we tried to pretty much stay focused on grams to moles, moles to grams. Now we're going to start making more use of this 22.4. We have to keep an eye on that as being an operation where we could make conversions from grams to liters. Now, one of the details of that conversion that we just kind of ignored while we were talking about this, however, is that it is at STP. That is standard temperature and pressure. So that means it's at 0 degrees Celsius and 1 atmospheric pressure. So that means it's here out every day outside when it's 32 degrees. And what that does is that eliminates any moisture that could be in the gas sample, because it would freeze out. And so we would have just a pure gas. That's why we measure it at STP, so we don't have any contaminants into the gas. All right. One of the words I mentioned before is fluid. So I want you to be aware that gases and liquids are both fluids. We think about fluids as just being liquids, but gases also are fluids because they can easily be poured. They are free to move, and they can be compressed. That's one of the other details. Now, notice that liquids cannot be compressed as much as gases, and that's because gases particles are further apart, so it's easier for us to push them together than it is a liquid. They're a little closer together, so we can't compress them as much. All of this comes as we pull all the concepts together into something called the kinetic molecular theory. The kinetic molecular theory states that as you heat up a substance, it will move faster. The particles will get further apart and they will change their states of matter. So solids turn to liquids, liquids turn to gas, and eventually you will rip off the electrons and they will become plasmas. So as you heat up, you increase the energy, which increases the distance, which increases the speed, which changes the state of matter. Okay, so this is everything that I wish to share with you today about topic 1. We will pick up on topic 2 in just a second. Thank you very much. Bye-bye.